In this video, we're going to learn how to write a transformed quadratic function in vertex form. So before we start transforming vertex form, let's remind ourselves what vertex form really represents and the values that it contains. So multiplied outside of the parentheses here in vertex form is our a value, and this typically is dealing with your vertical stretch or shrink factor. Or it could also deal with a vertical flip or a vertical reflection. And remember, our vertical reflection is going to take place about the x-axis. We then have our b value, which is multiplied by x on the inside here. And this is going to relate to our horizontal stretch and shrink factor. And it's also going to deal with that horizontal reflection, which remember is going to be our y-axis. Then here inside of the parentheses with x being added or subtracted is our h value. Remember, h is working opposite of what we expect, and h is going to be our horizontal movement. And again, note this subtraction is reminding us that it works the opposite of what we expect. And then from here we have our k value, which is our vertical movement. So that's how we move up and down. So let's go ahead and jump in and start transforming our parent function here of f of x equals x squared. So what I'm going to do to start off is before I even start working on my transformations, I'm actually going to create my next function. I'm going to call this g of x. And I'm going to put the parentheses around x with the squared on the outside to start. So that way when I start transforming this function, I already know where my parentheses are and where the outside of my parentheses might be. So the first thing that we're asked to do is we're asked to do a reflection in the x-axis. So if we reflect on what we know about vertex form, we know that the x-axis is a vertical reflection. And as a result, this is going to be a multiplication on the outside of the parentheses of -1. So what I'm going to do here is I'm going to multiply the outside of this entire function by -1. So after my first transformation here, I end up with g of x is equal to a -1, and then in parentheses x squared. And you can just write a negative on the outside if you'd like as well. You don't actually have to have the 1 there. Then from here, the next piece is we're going to vertically stretch this by a factor of 2. Remember, our vertical stretch is our a value, so we're going to multiply the outside of this entire function by 2. And as a result, we're going to put a little parentheses around it, multiply this outside by 2. That is going to vertically stretch it up to be twice as tall. So we have -2 now on the outside, x in our parentheses, and then the squared on the outside. So we've taken care of that one. The next one we're going to look at is a translation down 3. That's my k value, so I'm going to subtract 3 from the outside here, so subtract 3. And as a result here, I have g of x is equal to -2 x squared minus 3. Now, because I didn't need to add anything inside of the parentheses here, I can actually drop my parentheses and just write -2 x squared minus 3 if I want. Either one of these would be fine. If you like to leave the parentheses in, there's no problems there. So we've now performed all 3 of those transformations onto our parent graph of f of x equals x squared. So for this example, I'm going to transform a different child graph. So I'm going to start by writing this out. This one is kind of nice because the parentheses are already written in here for me. So the first thing it asks me to do is it asks me to translate it down 3 units. Now that movement down is a vertical change, so it happens on the outside of the parentheses, and this is going to subtract 3 from the outside. So it's going to impact my k value in some way. So I'm going to subtract 3 from the outside, and here I end up with g of x is equal to 3x plus 6 quantity squared minus 7. So then from here I'm going to move on because I've taken care of that first transformation, and I'm now going to look at the reflection in the y-axis. And I know that reflecting over the y-axis is going to be a horizontal reflection, so I'm going to multiply the inside by a -1, and that's going to multiply this piece right here by a -1. So I multiply that by a -1, and I end up with g of x is equal to, in parentheses, -3x plus 6, the quantity squared, and minus 7 on the outside. Then from here, this next change, we have a horizontal stretch by a factor of 5. Remember, our horizontal stretch utilizes our b value, but if we think back to what we learned about the b value back in Chapter 1, our b value is something that we actually have to calculate. Remember, that's going to be 1 over our factor here, which is 5. So we're going to take this 1/5 and we're going to multiply the inside here by 1/5. So we're going to multiply that -3x by 1/5. If you want to do that multiplication off to the side, that's not a bad idea. So 1/5 times -3 over 1, which becomes a -3 over 5. So that new coefficient of x is -3/5. So my new function here would be g of x is equal to, in parentheses, -3/5 x plus 6 all squared minus 7. So there we have all three transformations there. In final example here, we're going to transform another child function, and this one also has the parentheses already written out. So we're going to start with -2 parentheses x minus 3 squared plus 1. And then we're going to look at the first translation here, and we see this first translation is moving the graph right by 3 units, which means it's going to impact our h value inside of here. What that's going to do is it's going to move it right 3 units, which is a +3, which, remember, h does the opposite, so we're going to subtract 3 from the inside here. So in order to do that, we have g of x is equal to -2, and then we have x minus 6 quantity squared plus 1. So we've taken care of that first one. Then if we move on to the second one here, it's a horizontal shrink by a factor of 2/5. Remember, our horizontal shrinks deal with our b value, and that's something that we have to calculate. So we have to do 1 over 2/5, which is really just the reciprocal. So we flip it over and our b value becomes 5 over 2. So we're going to multiply this x value inside of here by 5 over 2. So that's pretty easy when it's just a 1 in front of the x. So this just becomes g of x is equal to -2, and then in parentheses we have 5 over 2x minus the 6 quantity squared plus the 1 on the outside. Then from here we have a vertical stretch by a factor of 3. Remember that a vertical stretch happens on the outsides, so we're going to multiply the entire outside by 3. So I'm going to multiply this entire chunk by 3, which really multiplies this 1 by 3 and this -2 by 3. So now we have g of x is equal to -6 in parentheses 5 over 2x minus 6 all squared. And then if I multiply the +1 by 3, we get +3. Then we've taken care of that one, and the last thing we have is a reflection in the x-axis. Remember, this multiplies by a -1 on the outside because it's a vertical reflection. So we're going to multiply by a -1. So we're going to multiply the 3 and the -6 by a -1. So we end up with g of x is equal to, that becomes a +6, 5 over 2x minus 6 quantity squared, and then that becomes a -3.